Hi everyone, my name is Ankita Petnikar, and today we're going to be working on sprint number 14 from the 12402 release. So let's get into it. Let the function f of x have the following properties. F of 1 is equal to 2, and for all integers n is greater than or equal to 1, f of n is equal to f of n plus n. Given that f to the power of a of x is equal to f of a times, compute f to the power of 11 form. So typically the first thing when you have these kind of functions that are within functions, or you have a bunch of functions that relate to each other, typically the first thing you should do is try to substitute simple values so you can kind of deduce a pattern and induce the rest of the problem. So for this problem, let's start off with the fact that they gave us f of 1 is equal to 2. The next step we can do is take the second statement they gave, which is f of n, which is equal to f of n plus n. So if we substitute using f of 1, we would have that f of 1, this is equal to f of 2, since f of 1 is equal to 2, and this would be equal to f of n, which is f of 1, plus n, which is 1. And this is going to equal to 2 plus 1, and this is going to end up equaling to 3. We can continue this kind of steps. So we can take f of 2, and this is going to be equal to f of 3, since f of 2 is equal to 3. And then we would have f of 2 plus 2, which equals 3 plus 2, which is equal to 5. The next step we can take is have f of 3, and f of 3 is equal to 5, so this is going to be f of 5, and this is going to equal f of 3 plus 3, and this is going to equal 5 plus 3, which is 8. So hopefully you're kind of getting the gist of, or slowly starting to see the kind of pattern we're starting to get, but for the sake of it, I'm going to do one more. So we're going to have f of 5, and this is going to equal to f of 8, and this is going to equal to f of 5 plus 5, which is equal to 8 plus 5, which is equal to 13. So let's look at the kind of values we're getting. So we have 2, 3, 5, 8, and 13. So if you maybe stare at the problem long enough, you're going to start to see that we actually have the Fibonacci sequence, as 2 plus 3 is equal to 5, 3 plus 5 is equal to 8, and 5 plus 8 is equal to 13. So if you write out each of these values we have so far, so we have 2, 3, 5, 8, and 13, we can have that f of n is equal to f of n minus 1 plus f of n minus 2. And from this, we can kind of compute the next powers of f of 1. And currently we're at f of 5. So for f of 6, this is going to be 8 plus 13, which is equal to 21. And continuing, we're going to have 21, 34, 55, 89, 144. And this is going to be the 10th power. And finally, for our 11th power, we're going to have 233. And this is going to be equal to f of 11 to the power of 11, 1. And hence, 233 is our final answer. So that means the answer for this problem is A. Thank you, everyone.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.